So, hello everyone. Today I'm with the set of me Lê Quang Kiều, Nguyễn Đình Tiến là Axel leader của thành phố. Nguyễn Thành Phúc and Đặng Quang Minh will introduce about our project, alcohol monitoring and knowledge system for car. So first, like a set of four main sections to the problem integration, the adoption statement and define specification and conceptual design. First, in my section, problem identification and also existing problem, which we select traffic due to the high rate traffic accident. Which you can see by everyday news, there will be one section about traffic accident, which causing by poor infrastructure like pothole or the survey or some lack of red line and the red line or red light driving. And the last is the degree of competition and the line for energy field. We have to compete at EVN and we can ensure having that our grid without causing some conflict. So here are some existing problems that we do research. First is the reckless driving and overspeeding, then is the driving under the influence of alcohol, then the not wearing with the helmet when participating in traffic, and also the problem of air pollution caused by vehicle, and the last is the red light. So after conducting the interview, these are the five people that will provide the most sophisticated answer. We have Mr. Mao, Long, Mr. Hậu, and Mr. Young for that up negative point of view toward the drunk driver, and Mr. Phương experienced the DSS with them. So we also conduct some research upon the situation in Vietnam with 10% of traffic accident usually involve driving, as you see. Then 40% of traffic accident and 11% of death are alcohol as well. And this is the special article within the topic on the world of engineering and technology article, which summary the work of in 2016 to 2023 about traffic accident and indicate driving the grand third with traffic law. So after scoring beyond the five category, as you see, impact, society, ethics, unique, and visibility, we select the UI. And here the need and audit statement from these five people, these three are will want to have forbid the drunk driver to participate in traffic, and the first and the fifth one us to apply technology. So remain on A, we cover that we need a model solution to detect driver intoxication and also one driver and driver awareness. So what is the object statement from this? It must have to detect alcohol level, then display warning and using alcohol alert, also send real-time alert for tracking. So here's the next session.
The next we will come to requirement and specification. The first one to know the market, and we will study the market to know the customer needs, and the customer want to system that raise awareness, prevent to secretive, deliver with time and accurate alerts. Moreover, the customer also want to affordable, easy to use, capable of data management. Next is marketing list. The table 5 highlight that warning system and restriction are critical. Rank at 5 to align safety with command and real-time analytics and database reliability score for ensuring effective monitoring and affordability and easy to use. Rank Act 4 and 3 respectively are vital for widespread adoption, supporting Vietnam to both to review DUI violations and note the DUI driving under influence. To rank these, we wrote this into develop, price, easy to use, performance, connection, and durability, and pairwise comparison from table 5, from table 7 to table 15, highlight that price, connection, and performance, ranking height, followed by the easy to use and durability. And here is our objective 3 outline award. The top one is prevent alcohol monitoring, and it ranks into easy to use, performance, durability, listen, and price. And sub-objective 3 improves wireless connection, low battery, user interface, low cost, and fast processing.
Okay, I'm Đạt, and now I'm going to talk about the engineering requirement. As Phúc had mentioned before, we have a lot of marketing requirements, but we have summarized into 5 main ones, which are it should have the low price, easy to use, good performance, consistent connection, and it can withstand external damage. From the marketing requirement, in order to satisfy those needs of customer, we conclude the engineering requirement. Our system should be at the high accuracy, reliable sensation. Detection speed should not be too have too much latency, and it should be easy to use. Also, the dimension should not be too big, and the weight should be under 700 grams. The device should have low cost of under 1 million Vietnam đồng. Next is the trade-off metric. Before talking about our trade-off metric, I'm going to tell you about the definition. This is the correlation between the requirement, which are the marketing requirement on the left side, and the marketing requirement on the left side, and the engineering requirement on the top. And the symbol plus or the minus is the way we want the requirement as high as possible or as low as possible. For example, this is a good performance to accuracy. We want the good performance as high as possible. So that would mean the accuracy will be have a really strong positive correlation. Or another example is the price compared to the accuracy. When the price is really low, we cannot buy a good hardware. So that means the accuracy will be down and the correlation will be strong negative. Next is the engineering trade-off metric. It is the same as the marketing to engineering requirement metric, but it is the engineering compared to itself. And we have our after repeat and repeat, and we have our trade-off metric. Now, in order to make the house quality, we combine the body, which is the engineering to marketing requirement metric, to the rooftop, which is the engineering to engineering metric, and at the bottom is the target for engineering requirement. And finally is the competitive benchmark. At this step, we compare our product with the other 3 devices on the market, and we find out that our device is really cheap, getting much cheaper than the other 3. It's only 1 million Vietnam đồng. And furthermore, we have a really fast installation time, which is only under 10 minutes, and we have a unique feature no other device has. That is the real-time report based on web, and also the voice alert. Next, my friend will talk about the conceptual design.
And in this our system, we the inputs into the power supply, pressure point, user control, and through the system, the outputs will be PIC identifies the web display and voice alert to when this is the threshold. And infrastructure this is our overall system. Firstly, in level 1, the sensor has a mission to provide the actual concentration to have a sensor data. And the user can have the control signal to control the component and status of the system. The data from the sensor is then processed in the microcontroller, which is manage the power supply, electrical and data. And then if the data exceeds the threshold, the voice asset will be active. And the communication has been used to send the data to the data store to display in the data store. And in level 2, the communication in level 2, the communication unit will be defined when the communication defined will transmit the data to the database to restore the data log before sending them to the data store.
And I'm talk about the contextual design. And for the system general diagram, the picture shows the functional decomposition of system. The system of CPU 5 function, readiness detection, display information, alert, data management, and final service platform. And the component section, the table shows the device for system, and the report are defined are compatible for the system with the system. And there is the analytical memory process and decision matrix. And if you do find 4 steps. Step 1, determine the selection criteria, user interface, sensor, microcontroller, case, and network. And step 2, determine criteria way, power-based method. And this is the view one equal, and this is the view over cost 3 over 7, and way and make view utilize all the our 3. The same play we have the table microcontroller case and network. Step 3, identify and write option to the criteria and example calculate ECDU. ECDU import from 0 to 10 and calculate the application logic and normal ECDU writing. And the same calculate, and we have the table user interface, sensor, microcontroller, case and network. And after perform the following action analytic process, we are select the 4 components on the system. And the user will choose the best platform. Alcohol sensor MP3, connectivity Wi-Fi, case method recall management, and power PC, alert DX player MIDI, microcontroller EPH32, Google and database file base. And
the features of our analysis for the system. And thank you for listening.